All right, Geometry, Chapter 6, Section 6. We are looking at trapezoids and kites. And so a trapezoid is similar to a parallelogram. It is a quadrilateral, but in this case, a trapezoid has, has only one set of opposite sides that are parallel. Okay, so only one set of sides, one set of opposite sides that are parallel. So obviously in this case, this side is going to be parallel to this side. My great coloring job there. Okay, so those are the opposite sides that are going to be parallel. Because they're a little bit different, they do have specific side labels. This is a base. And if I flipped it upside down or any other direction, this could be the base. And that makes the opposite sides that are not parallel, that makes them legs. Okay, so I've got bases and legs. If I labeled this A, B, C, D, then angle A, angle B, angle C, and angle D, those are all called base angles. And because it's a quadrilateral, obviously all of the base angles would add up to be 360 degrees. Again, a base angle is where a leg comes together with a base, and those are the vertices there. Okay. Okay, so let's look at a specific trapezoid. This is going to be an isosceles trapezoid. Okay, this is an isosceles trapezoid. And what makes it an isosceles trapezoid are two different things. Let me go ahead and label this A, B, C, D. Let's say that if the base angle A is congruent to the base angle D, okay, so this is congruent to this, then that makes this an isosceles trapezoid. That also makes this angle congruent to this angle. So angle B would be congruent to angle C. And because it's isosceles, it has two equal base angles, and it also means that it has two equal legs. So AB is also congruent to DC. Just label those properly. Okay, so all of those traits in an isosceles trapezoid. And there's one more condition that would make this an isosceles trapezoid. If my diagonals are congruent okay, if that diagonal is congruent to that diagonal, then that also makes it an isosceles trapezoid. Okay, so congruent base angles, opposite sides congruent, the opposite legs, excuse me, congruent, and if the diagonals are congruent, all three of those properties can be used to prove that it is an isosceles trapezoid. Okay, what we're going to talk about next is the trapezoid mid-segment. I didn't write that very well. I hope it recognizes it. Kinda. Who would put that as one word, but that's all right. Oop. The trapezoid mid-segment. Basically what I've done is I've taken the midpoint of AB, which is E, and I've taken the midpoint of DC, which is F, and I have connected those two midpoints. Now what that does is that makes all three, and I'm just going to draw the triangles on them, not spend the time coloring them in. Never mind, I couldn't do that. That would drive me nuts. So I went ahead and colored them in on my time and speeded it up for you. Okay, so those are all parallel. What that's going to tell me is my mid-segment, which is EF, is equal to, if I add my other bases, and I divide that by 2. You can also look at that as EF is 1/2 of BC plus AD. Either way is fine. Add them together and divide by 2, or take half of them added together. It's the exact same process. Okay, let's look at an application of the mid-segment. And so I know that the top one is X, the middle one is 15, and the bottom one is 18.2. So my formula tells me that EF is equal to BC plus AD divided by 2. So now let's fill in things that we know. We know what EF is. We don't know what BC is, so we're going to represent that with X. And we know that AD is 18.2. And do all that and divide by 2. So now we just solve it algebraically. Let's multiply both sides by 2. So that gives me 30 equals X plus 18.2. Subtract 18.2 from both sides. And that gives me an answer of X equals 11.8. Now I would look for in the problems if they gave it to you in feet or something like that, make sure that you represent that. So let's go to kites. Okay, if we have a kite, let's look at some of its properties. A kite is going to have diagonals. Oop, don't like that one. It's going to have diagonals just like any other quadrilateral. That's a little bit off there. But my shape is a little bit off, so we'll go with it. A little human error on this one. By definition of a kite, very similar to a square or a rhombus, its diagonals will form a 90-degree angle, or its diagonals are perpendicular. Okay, so diagonals are perpendicular. Okay, so another property for a kite is it has exactly Okay, and I'm going to leave that in all caps. Very, very important. It has exactly one pair of opposite angles that are congruent. Okay, exactly one pair. So let's call, let's go with a blue. This angle here is congruent to this angle. If the other set of opposite angles are congruent, then it is not a kite, because again, it can only have exactly, okay, exactly one pair of opposite angles that are congruent. Okay, so that was our last two remaining quadrilaterals, the trapezoids and the kites. And so we're looking at a little over 11 minutes. Chapter 6, Section 6, Trapezoids and Kites.